Hello everyone and welcome to the channel. This video is a full course designed to take you from a beginner in Python to the intermediate level. My style for this tutorial and all my other ones is very quick and to the point. So if you like this type of content, feel free to subscribe to my channel or drop a like on this video. With that being said, I hope this course teaches you Python in the most effective and efficient way. Let's begin our first video of downloading Python. Hello everyone. In this video we'll talk about how we can download Python and start using it. You might already have Python installed in your system if you're using a Mac like I am. So if you open up a terminal, you might be able to type in Python and see a Python shell. That's because a lot of MacBooks already come pre-installed with Python on them. We see that this version though is Python 2.7, and this isn't what we want to use. Python has two different versions. Python 2 is the legacy version of Python, and Python 3 is the new version. We want to be sure to use the new version because this is what will be updated in the future. So let's go ahead and close out of this, and then we'll open up a window and pull up the page python.org/downloads. And we see that the newest version of Python right now is 3.7.3. Let's go ahead and download this. And we see it downloading in the bottom left corner. Whenever it finishes, we'll open it up. We'll go through the installer.
A few moments later.
And it looks like we've successfully installed Python 3.7. We'll close this and move it to the trash. Now that we have Python 3 installed, we should be able to open up a terminal again. And this time, instead of typing Python, we'll type in Python 3. So this is denoting the version Python 3 instead of the default factory Python version 2. We'll hit enter. And now when we enter this into the terminal, we see that we're running Python 3.7, and that means we're good to proceed. We'll go ahead and close out of this, and close out of this one as well. Now the next step that I want to do is to get a text editor. Let's go back over to our window, and we'll type in atom.io. And this is the text editor that I'll be using in this course. So Atom is just an open source text editor. So that means that the community can build packages and themes for it to improve our experience using it. We'll go ahead and click through and download this. I already have it, so I'll just open up my Atom text editor. This is what the default view of Atom looks like. We'll go ahead and click Atom, and then we'll drop down to Preferences. And there's a few packages that I would recommend to install for this course. The first one is autocomplete-python, which is just an auto-completion tool that we can use when we're coding in Python. And then platform.io-IDE-terminal. What this does is it gives us this little terminal down here in the bottom left corner that we can open whenever we want. This by far is one of the most helpful packages for me whenever I'm coding. So I would encourage you to get those two. And then the themes that I'm running, if you want to follow along completely with how mine looks, is OneDark in the user interface theme, and then for the syntax theme I use OneDark as well. You don't have to choose these themes, and there's a lot of created themes from the community as well that you can use. But these themes are very nice for me because they show up brightly whenever I'm recording videos. I'll go ahead and exit out of the settings and jump back up and create a new file. I'll increase my font size. First thing we should do is hit Command S, and we'll save this as a Python script. So every Python script ends with the extension py. We'll say example.py and click save. I already have one, so I'll replace it. Now Atom automatically gives us a directory here as well. So since I'm working in my desktop, everything on my desktop appears here. This is very useful for navigation whenever we have large projects. But for now, since we just have one script, I'll go ahead and close it. Let's go ahead and create our first Python script. So the very basic one that everyone does and that you have to do as well is using the print function. A function is just denoted by the parentheses after a word. So here we have the function print, and we know it's a function because of the parentheses. This function takes in whatever you pass here of the same data type and prints it to the terminal. So let's say hello world. We'll save our file. We'll go ahead and go down to that terminal, and then we'll type in Python 3 and then the name of the file. So ours was example.py. Hit return. And we see that the return to the terminal is the hello world that we passed through the print function here. And congratulations, you just wrote your first Python script. We'll keep on building on this, but for this video, it's important that we have Python downloaded and we have a text editor ready to go. I'll see you in the next one. Hey guys, welcome back. In this video, we'll talk syntax and commenting. Let's get started. So back in our text editor here, we have the print hello world statement from the last video. Now let's talk about how we can make a comment in our Python script. A comment in a Python script is just a line of code that isn't executed. So these are often notes for developers or programmers. So we can leave notes in our Python scripts throughout to let us know what we were thinking at that time. If we wanted to put a comment above our first line of code, we could drop that line of code down and then use a number sign. This number sign just denotes a comment, and this line is not read whenever we execute the Python script. What we'll do is we'll put the number sign and then try to always put one space after your comment. Then we'll pass in the comment that we want here. So this is our first Python script. And that's how we would make a comment in Python. Block comments in Python are done the same way. So if we wanted to do a block comment, we could drop down, put another pound sign, and then put in another line of text. This is a comment. The more comments you put in your script, the better it usually is, because this means that someone else can pick up your Python script and understand what you were thinking whenever you were writing it. Since Python emphasizes the ability to be able to quickly look at a Python script and understand what's going on, comments are always a good thing. Now let's talk about the syntax of Python. Python is one of the few programming languages that uses white space. Let's say that we have a block of code that looks like this. We have a variable x is equal to 1, and then we want to make a simple function. So if x is greater than 0, we'll put a colon here. Now watch what happens in the text editor whenever I press enter. It automatically spaces over 4 spaces. So whenever we have an indented block of code, we know that the control flow happens here. We know that anything that happens here belongs to this if statement. We'll use our function print, and then we'll say x is greater than 0. We'll save our file. We'll drop back down to our terminal. We'll execute the script again by pressing up, and then we'll hit return. And now we see we get the return x is greater than 0. This is because x is equal to 1, so therefore it's greater than 0, so we get this command. We see that if we were to change this to a different logic statement, so x is less than 0, hit save and execute again, we see that we don't get the return in this case. But we can drop down and put an else statement. So else here we see is lined up with the if statement. That just means that this new block of code doesn't belong to this if statement. It's actually its own statement, but whenever we drop down to the next line, it should be indented, which it is. We see that anything we put here now belongs to the else statement. So this is a new block of code. We'll use the print function again. X is less than 0. Now when we execute, we see that we get that return. Indentations can be thought of as just blocks of code. Here we have 2 blocks. Each control statement is at its own indentation level. We see that the if is lined up with the else. Each block of code following the logic statement is at its own indentation level. Each indentation level is just 4 spaces from the last one. Here we may be tempted to hit tab whenever we're indenting, but tabs may not be consistent across operating systems. So it's encouraged that we use 4 spaces to do this indentation. It's okay if you don't quite understand the logic of the if and else right now. All that's important for this video is that we understand how we can make a comment and also how we can indent blocks of code. In the next video, we'll dive into variables and data types. I'll see you then. Hey everyone, welcome to the next video. In this video, we'll talk about variables and data types. Let's get started. Back in our Python script where we left off, close our terminal and go ahead and delete everything in our Python script. So let's go ahead and drop down and create a variable. We already did this once where we set x equal to 1, right? But variables in Python need to be descriptive. Right now, since we're just starting out, x as a variable is fine, but in the future, a variable name should be something that actually makes sense. This could be something like age, maybe name, or something along those lines. Right now, let's go ahead and use the age variable. The first thing about variables is that we should type them with lower cases. Here, I put age with a lowercase instead of age with an uppercase. With the capital A, this may confuse people that have been using Python for a while because we tend to leave the capitalization to the class objects. Let's go ahead and change this to age with a lowercase, and this is now a variable. The cool thing about Python is that we don't actually have to explicitly state what type of variable we have. All we have to do is type in what we want this variable to equal. You already saw how we set the last variable x equal to 1. We can do the same thing with age here. So let's save our file, and then we'll drop down and use the print function again. And now let's introduce a new function. Let's use the type function, and then we'll pass in the variable that we want to this function. We'll say age here. What the type function does is it returns the data type of the variable that we pass to it. Let's open up our terminal again and type in python3 example.py. Make sure you have your file saved, and then we'll hit execute. And now we see that we returned a class of an integer. Python has a lot of different data types, but let's just talk about 3 main ones right now. Integers are just positive or negative whole number values. Here, since 1 doesn't have a decimal place, it's an integer. If we were to change this to 1.5 and execute our script again, our class now changes to a float. A float is just any number that includes a decimal point. Lastly, let's talk about how we can make a string. Instead of typing in a number, let's put in something called a delimiter, which can either be a double quotation mark or a single quotation mark. and then we'll pass in text. Drop down in executing, and we see that we now have a string class. This is something that a lot of beginners really enjoy about Python. We didn't need to denote anything other than what we wanted the value to be for a variable. In other programming languages, you would typically have to state what type this value is whenever you assign it to this variable. In Python, it does all the heavy lifting for us and automatically places a type to this value. This can get us in trouble sometimes though, because what if we want a float number and Python thinks it's an integer value? Let's drop down and say number. We'll set this equal to the number 1, but let's say that we wanted this to be returned as a float number instead of an integer value. We could just use something called casting in Python. What we'll do is we'll say float and then use it as a function and pass in what we want to be a float number. Now, instead of this returning as an integer, it should return as a float type. We'll drop down and say print type and then number. When we execute, we see that we're given a float, even though the default behavior in Python would have been an integer. We have access to do this with string, int, and also float. Lastly, let's talk about how we should create multi-word variables in Python. Let's drop down and say number, and then for the second word, we should put in an underscore to separate the two words. So number, and then let's say and age. We'll set this variable equal to a tuple, which we'll talk about later on in the course, and we'll say number and age. Now we can drop down and print number and age. When we do this, we get the return of both of these in a tuple to our terminal. Don't worry if you don't quite understand this tuple yet. We'll talk about that later on. What we should take away from this lesson is that variables can be uppercase, but we should keep them lowercase and separate multi-word variables using an underscore. We also have access to a lot of different data types, and we're able to explicitly state those data types using casting only if we want to. Lastly, Python makes it very easy for us to create variables because it automatically assigns a type depending on the value of the variable. If you got all this, you're good to move on to the next lesson. We'll talk about composite data types. I'll see you then. Hey everyone, welcome back. Let's talk about composite data types in this lecture. The first thing we need to talk about is an immutable and a mutable data type. Simply put, a mutable data type is something that we can change once we create it as a variable. An immutable data type is one that we cannot change once we create the variable using that data type. We'll talk about this more whenever we get to the specific data types, but we just need to remember mutable means changeable and immutable means that we cannot change it. But for now, let's talk about the composite data types that we have available to us. We can create a list, a tuple, a dictionary, a Frozenset, and also a set. Let's go through the structure on each of these. We'll start out with a list, so we'll create a variable and say our list. We'll set this equal, and now a list is denoted using square brackets. So we'll use 2 square brackets, and everything that we put in between these square brackets belongs to the list. So let's say that we want to pass in A, and then put a comma, B, and then C. What each of these composite data types do is allow us to put multiple values to one variable. Each one of these just allows us to do it in a different way. For a list, we're able to pass in multiple values, and we're able to keep the ordering of the values in the list. So the first value will always be A, and the second value will always be B. A list is also able to store multiple data types. So if we were to put another comma and put 1.5, drop down and say print our list, save our file again, and then we'll execute this script. So Python 3 and then example.py. And we see that our list is returned in square brackets of multiple different data types. We have strings here because we know the delimiter means a string, and we also have a float number because we have a decimal place here. A tuple is almost the same thing as a list except that it's immutable. We'll talk about that later on in our list video, but for right now, we'll just look at how we create them. So we'll say our tuple equals, and then instead of square brackets here, we'll use parentheses. Now we can do the same thing as we did before. So we'll say A, B, and then also C. We'll drop down and print our tuple, execute it to the terminal. We see that we get the same thing, except it has parentheses instead of the square brackets. Now let's talk about a dictionary. So we'll say our dictionary, and then we'll set this equal to curly brackets this time. And instead of just having one single value in a dictionary is composed of a value and a key. So these pairs are what make up a dictionary. We denote these by using the key first, a colon, and then the value. So let's say our key is key 1 as a string, and then our value will be value 1. Now a dictionary is powerful because we can pass in multiple pairs into the dictionary for storage. So we can say key2, colon, and value2. We'll print this out, so our dictionary, and we'll see what the return looks like. The dictionary is returned the same way that we type it. Dictionaries are useful whenever we have multiple properties about something. So let's say we change the key to name, and then we'll use my name, so we'll pass in Derrick, and then we can change the second key to another property about me. So let's say key2 will be equal to height, and then we can say 6 foot. Now let's go ahead and talk about a set. So we'll do this one first. We'll drop down and say our set. And then sets are created using curly brackets as well. But instead of key value pairs, it's just single elements. So we'll say 1, the second one 2, and then the third one 3. We'll go down and print our set. And when we print, we see that we have a set here. But what's the difference in using a set and using a list? Well, a set is unordered. That means it doesn't keep the order here. So we see that 2 is in the first position instead of in the second position, like how we put it here. And then it also has to be unique. If we were to include a repeat, so let's put 2 again and save this, we should only be returned one string 2 in our set. Here we see that's exactly what we get. These are useful if we're doing unions or intersections or something of that nature. Now for our last one, let's say our frozen set. And a frozen set is just like a set in the same way that a tuple is just like a list. A frozen set is just the immutable version of a set. We can use frozen set and then pass in the set value that we have. We'll drop down and say print our frozen set, and it should look very similar to our set. We see that it does, except that it has the parentheses around it, denoting it as a frozen set. We'll look at what we can do with mutable and immutable objects in the upcoming lectures. For now, we just need to know that there's a variety of different composite data types that we can use in our Python scripts. I'll see you in the next video. Hey everyone, let's talk about numbers in this lecture. Let's jump right in. Let's create a new file since I don't want to get rid of this one. We'll save this one as example2.py. Close the terminal. And now let's go ahead and import our first package called math. To do this in Python, all we need to type in is import and then the package that we want. This one is just called math. And the math package just gives us access to a lot of different operations that we can do on our numbers. We'll drop down, and we already know that we can create integer values, and we can also create float values. Python also gives us access to use complex numbers. We'll say z is equal to the real part of the number, 2, and then plus 3j. The j here just denotes this number as a complex number. If we were to drop down and say print type of the variable z, open up a terminal and execute our Python script, so python3 example2.py, we see that the class is complex. Let's go ahead and close this. In Python, it's very easy to do math operations because they're already built in. We can drop down and say result equals, and then x plus y, and print result to the terminal. When we execute this, we're given the addition of y plus x. You see that Python doesn't care about these two data types being different. If we wanted to do multiplication, we could use an asterisk. If we wanted subtraction, we could use a hyphen. And if we wanted division, we could use a slash. These are all built into Python already, so we don't have to do anything special to use these. However, let's talk about how we can use the math function that we did need to import. Whenever we imported this into our Python script, it gave us access to a lot of new functions that we can use. We can look at the documentation on the Python website, but all of these represent some type of new function that we can use in our Python script. Well, let's go ahead and use one of these. Let's say we want the ceiling. The smallest integer greater than or equal to x. We'll go over, and to use that, we saw that we need to type math.ceil and then pass in the value. So let's drop down and say print math.ceil, and then we'll pass in the value. So let's pass in y. We'll save the file and execute. And we see that the ceiling function did exactly what we thought it would and returned the lowest integer higher than our number. In this case, that was 2. It's okay if you don't quite understand this part just yet. We'll have a whole lecture on how we can start using packages that other people have built and using their functions inside of them. So don't worry just yet if you don't understand this. But what we should understand from this video is that we have 3 different data types and numbers, where we have integers, floats, and complex numbers. And we also have the ability to do simple math operations already built into Python, such as addition and subtraction. And that's pretty much it for this video. I'll see you in the next one. Hey everyone, in this video we'll cover Python lists. Let's get started. In our text editor, let's go ahead and open up a new file. And I'll go ahead and close these out, that way we don't have them. And now the first thing we need to do is let's create a list. So we'll say our list, and then remember we denote these using square brackets, and then we pass in objects into these square brackets. So let's say A, and then we'll say B, and then we'll say C as well. I'll save our file, that way we get the highlights. So let's say list.py. And remember that a list can be a multi-type container. So we don't have to put in just string values. We can put in integers, float numbers, and any other data type that we want as well. We'll drop down and say print our list. Saving this and executing it. We'll say list.py. And we see that we returned a list in the terminal. So we know how to create a list, and we can do it just like this. But if you remember, a list is also a mutable object. And that just means that we're able to change it once we create the variable here. So if we wanted to change the rList variable, we could drop down and say rList, and then if we wanted to add something in, we could append it. So append parentheses, and then we can append whatever we want here. So let's say we wanted to append the letter D. If we were to print rList again, we'll see that we have a new list in our terminal, which we see that we do. We now have the string D and our list value. This is possible just because a list is mutable. If we tried to do this with a tuple, we wouldn't have the same result. If you remember as well, a list also keeps the order of the elements inside of it. No matter how many times we were to print our list, this will be the order of these elements. Since this data type keeps the ordering, that means that we're able to index values out of it. Indexing is just using the index position of an item inside of a data type to pull a specific element out of it. Let's try to only pull out the element A from our list. We could drop down and say print our list, and now anytime that we index values out of a data type, we'll use a square bracket. So we have our list, which is the variable here, and then we're using square brackets to pull out certain values within our variable. So if we're only trying to pull out A, Python starts in the 0 index position. And what that means is that A is in the 0 position. So A would be 0, B would be 1, C would be 2, and so forth. To pull out A, we use a 0. So I'll put a 0 here. And now when we execute, we should just be returned A, which we are. Like I said, a list keeps the order, so that's what makes this possible. It also makes it possible for us to insert elements at a certain position within our list. We'll drop down and say our list, and then we'll insert parentheses. And now we specify the index position of the place that we want to put the element. So let's put it at the very beginning. And now we'll put in the element. We'll put in first element as a string. Now, when we print our list, we should have a first element string at the very beginning of the list, which we do. We're also able to remove that element from the list if we want to. We can drop down and say our list.remove, and then specify the element that we want to remove. So let's specify first element, and now when we print our list, we shouldn't have that element in our list anymore, which we don't. We also could have done this using the pop method. If we wanted to remove a certain index position from our list, we could have used pop. We'll put parentheses, and then we'll specify the index position that we want to remove. So let's remove the last one, D, which is in the 0, 1, 2, 3, 4, 5th index position. We'll put in a 5 here, and now print our list again. When we execute, we see we no longer have the string of D in the last position of our list. Lastly, we can nest lists inside of each other. So let's say nested list is equal to another list, and then we'll pass in a second square bracket, which will be just another list inside of the first list. So this will be the first list. So let's say 1, 2, 3, and then the second list will be 3, 4, 5. All we're saying is that there's one big list with a smaller list inside of it. We'll print nested list to see what it looks like. We see that it looks exactly like how we typed it in the terminal as well. And that's it for this video. It's important that we remember that a list is a mutable object and that we're also able to keep the order of elements inside of our list. I'll see you in the next video. Hey everyone, let's talk about how we can use strings in our Python scripts. Let's get started. Over in our Python script, I'm in a file called strings.py. We've already been using string variables quite a bit, but there's a little bit more that we need to talk about. Let's create a new variable called string A, and then if you remember, we use a delimiter to specify a string. A delimiter is either a double quote or a single quote. We'll use double quotes here. And now let's set this equal to a name. So we'll just use mine, Derrick. It's very easy to create strings in Python. However, there's a lot happening behind the scenes. This string in Python is actually an array. So if we were to drop down and say print, and then we'll use a new function called len, which just calculates the length of the array, we'll say length, parentheses, and then string A. Now when we execute this, we'll see what I'm talking about. We get the return of 7. That's because each letter in my name is actually a single element, and they all combine together to make this string, which has an array length of 7. So the same way that we were able to index list values, we can actually do that here too. If we drop down and say print, string A, and then the same way that we indexed before using square brackets, we can do the same here. So let's pull out the first letter of my name. So we'll use a 0. Now when we execute, we should just be returned a D, which we are. We also have a few different functions that we can apply to strings. I'll just show a few of these. We can say print, string A, and then we can use the function upper to make my name entirely uppercase. We see this in the terminal because every letter in the array of this string is now capitalized. We also have access to the reverse function of lower. We're also able to split strings in Python. So let's say string B is equal to my name, so Derrick, Matt, and then let's say Jessica. And now if we wanted to return each name individually, we could drop down and say print, string B, and then use split as a function, and then we'll pass in the character that we want to split on. So let's split on the comma value. We'll put parentheses and then a comma, save, and then execute our file. Now we see that we have 3 values of strings in a list. We have Derrick, Matt, and Jessica. So that's pretty much it. We know how to create a string. We know that a string is actually made up of an array of elements instead of just one element. We know that we can calculate the length and how to index a string. We now know that we have functions that we can apply to the strings, and we're able to split strings as well. If you have any questions about this, please let me know. I'll see you in the next video. Hey everyone, let's get started talking about tuples. Over in our text editor, let's go ahead and create a tuple. We'll say tuple A is equal to parentheses, cat, dog, and mouse. Remember that we specified tuple using a parentheses and that they're very similar to a list object. The only difference is a tuple is immutable. So this can be useful if you want to create a list but don't want people to be able to change it. We can create a tuple instead which is immutable and doesn't allow for that change. If we were to try to do that here, say tuple A dot append how we did in our list and pass in some type of value, so value, and save this and execute it, we should get an error in our terminal. So tuples.py. We see that tuple object has no attribute append. That's because it's an immutable object and we can't change it. So let's go ahead and get rid of this line of code. However, if you remember, a tuple does keep the order. Therefore, we are able to pull out values from our tuple using indexing. We can print tuple A, square brackets, and then let's pull out the word dog, which is in the first index position. We'll put in a 1, and now when we execute, we should be returned just dog. Tuples are one of the more uncommon data types that we have in Python. However, we still need to know how to use them. We can sometimes find ourselves using tuples whenever we're working in a coordinate plane. If we have a bunch of x and y values, tuples are probably the way to go. We use tuples from time to time, but really not that often. I'll see you in the next video where we'll talk about sets. Hey everyone, let's start talking about sets. Sets are just unique element containers. We already saw this briefly, but let's create another one. So let's say set A is equal to curly brackets, and then we'll create a set. Let's say 1, 2, and then 3. We also know that sets are mutable. We can see this by saying set A, and then we can add an element to a set. We'll put in parentheses the string 4 to our set A. We'll drop down and say print set A, and see what the return is to our terminal. Python 3, and then I accidentally typed over a previous script of tuples.py, but we see that a set is an unordered because we have 1, 4, 2, 3 in our return when we put in 1, 2, 3, and 4. So it's an unordered. That means we cannot use indexing on a set, and it is mutable as we were able to add a new element to our previous set. If we wanted to add multiple items to our set, we could drop down and say set A and use the function update. Now we'll put parentheses and we'll put in square brackets to create a list of items, and then we'll say 5, 6, and then 7. We'll print set A and execute it through our terminal. And we see that we can add one element using add, and we can add multiple elements using the update function. If we want to get rid of elements from our set, we can use the functions discard and remove. Remove just returns an error if the item is not in the set. Discard will just return none. Both of these are used the same way, so set A, remove, and then we can put in any element that we want. So let's remove the string 6. And now we should no longer have the string 6 in our output, which we do not. Now if we were to try to remove the same element again, and it's no longer in the set, we'll see the error that would get returned. So set A, remove, and then we'll remove the same element, 6. We'll just try to do this without printing, and then we'll say python through tuples.py. We see that we get the error, key error, 6 on remove 6. If we were to change the second remove function to the discard function, we should no longer get that error. When we execute, we see that it just returns a none, and we no longer get an error. Lastly, we're able to remove an element from a set using the pop function. We'll drop down and say set a.pop. And now this function is kind of dangerous because it's going to remove the last item in the set. However, we know that a set is unordered, so there's no way of knowing which item will be removed using the pop function. And since I'm such a fan of danger, we're just going to do it anyways. So print set A, and we'll see what happens. We'll execute. And from the terminal, we'll see that the string 1 has been removed. Remember that a set only contains unique values, so if we have multiple elements in a set that are the same value, the set will treat it like there's only one element of that value. A frozen set is very similar to a set, and we just use the frozen set parentheses, and then we can pass in set A to it. We'll create a variable, so f set A, and what our frozen set does is changes our set from a mutable to an immutable object. It means that we can no longer do these functions of remove, update, add to our frozen set. So you would use this whenever you wanted a set but didn't want any of the values to change. And that's pretty much it for this one. What we need to remember is that a set contains unique, unordered elements, and a frozen set is the immutable version of a set. I'll see you in the next video. Hey everyone, let's keep on going and start talking about dictionaries. Let's start off by creating a variable. We'll say our dictionary, and we'll set this equal to curly brackets, how we did before, and then remember that a dictionary is full of key value pairs. So the first item in the key value pair is the key. We'll say key 1, how we did before, and then value 1. We'll put a comma, and then we'll actually hit enter here and do our first multi-line variable. So then we'll say key 2, colon, value 2. We'll say print our dictionary, and then save our file. We'll type in python 3, and then the name of this file is dictionaries.py. We see that we have a dictionary made up of 2 key value pairs. Key 1 is related to value 1, and key 2 is related to value 2. Now remember that our keys can be some type of property. So let's say, how we did before, name, and then the value of name for me would be Derrick. We could say height, and then we can pass in 6 foot, so 6 foot. And now we can also keep on going and create as many key value pairs that we want. So let's say another one, and we'll say location, and will give me a location of lost. Dictionaries are very powerful to us, and we'll use them a lot. The reason why is we can use these keys to pull out information from our dictionary. Put square brackets, and then we can put name. This should return to us in the terminal my name, which it does. This makes it very easy for us to pull out properties values using a dictionary. We're also able to change these values because a dictionary is mutable. We can do the same thing, so we'll actually just take this line of code here, we'll copy it, paste it here, and then let's change the name. So instead of Derrick, let's say that my name is now Michael. Now we'll drop down and say print our dictionary. We're readily able to change the values in our dictionaries using this method. This is a very nice feature that you may use a lot. So we know that we can change values, but let's say that we wanted to add a new value to our dictionary. We could do the same thing that we did before, say our dictionary, and try to index a value. But if we change this value to something that's not already in the dictionary, we create it in our dictionary. So let's say I color is equal to blue. We'll print our dictionary. And since the key eye color is not already in our dictionary, it should create this key in our dictionary. We'll drop down and execute. And now we see that our dictionary has name, height, location, and also eye color. If we wanted to get rid of this, we could say our dictionary and then use the pop function that we learned in the sets lecture and pass in eye color. It is caps sensitive, so that's why you saw me backspace the capital E and replace it with the lowercase e. Print our dictionary. We should remove the eye color key that we just added in. We see that we have. Like I said, dictionaries are very powerful and they're a very good tool for us. The takeaways from this video are that dictionaries are made up of key-value pairs and that we can pull out values using the keys. I'll see you in the next video. Hello everyone, let's talk about if loops. Here in our text editor, let's go ahead and create 3 variables. We'll say x is equal to 1, y is equal to 2, and z is equal to 3. Now, to start an if loop, we need to use the keyword if. We'll say if, and then we need to pass in some type of logical statement. This can be anything like greater than, less than, not equal to. For now, let's say x is less than y, and then to end an if statement, we need to use a colon. Now we'll drop down and notice how we're indented over. That's because this block of code follows this logical statement line. So everything in this block will only be executed if this is true. We'll say print x is less than y. When we open up a terminal, we'll type in Python 3 and then the name of my file is if.py, and we see that this statement is true because we get this block of code returned to us. This is because x is equal to 1 and y is equal to 2, and 1 is less than 2. If we were to change this to greater than and execute our file again, we should get no return in the terminal, which is exactly what happens. In this situation, we need to create an else statement. If we go down and say else, then this means this line of code will only be executed if this line returns false. We'll drop down and see that it's indented as well because it follows this else statement. And we'll say print, and then we'll pass in victory. We'll execute, and now we should see victory in the terminal because x is greater than y returns false. We already saw that we don't have to include the else statement, but sometimes we want an action to happen whenever this statement is false. We also have access to a few different operators. Those operators are and or. We'll look at how we can use the and function now. Let's go ahead and change this back to less than. We'll use the keyword and. Y is less than z. We'll print to the terminal and we'll say something simple like yes. So the and keyword just means that both of these logical statements have to be true to get this action to happen. We'll go ahead and delete this else statement. And now when we execute, x is less than y and y is also less than z. So we should be returning this action to our terminal, which we are. Now, if we were to change this to y is greater than z and execute again, we should see no return in the terminal. That's because, like we said, one of these statements is not true, therefore the whole line returns false. If we were to change this to or, however, and execute it again, we'll get the return because in this scenario, only one of these has to be true to return the whole line as true. If loops are very straightforward and they're very powerful to us. All we need to remember is that we start an if loop with the keyword if, we have some type of logic statement, we end the line with a colon, and then we have an action underneath. We also have access to an else statement if we want something to happen if this line returns false. We'll get plenty of practice with if loops, so don't worry if you don't have it down just yet. I'll see you in the next video. Hey everyone, let's continue on and start talking about while loops. A while loop just executes a code while some condition is true. We need to create that condition, and the most common way that people do is they say I is equal to 1. To start our while loop, we'll drop down and use the keyword while, and now we need to say some logical condition. We already have I is equal to 1, so what we'll do is we'll say I is less than 10, and then we'll end our while loop statement with a colon. Now we need to create some action here. It's important that we don't create an infinite while loop, so we need to somehow make this variable I greater than 10 to end our while loop. So for each iteration through this while loop, let's say I is equal to I plus 1. Now we can do some type of action. So let's say print I. So looking at this, while this statement returns true, we want this action to be repeated over and over. We'll save our file, and now we'll open up a terminal and say Python 3 forloops.py is the name of my file. Hit return, and we see that we iterate through that action until I is greater than 10. Because we print I each time, and we see that we just iterate 2, 3, 4, 5, 6, and so on. While loops are very straightforward if you understand the syntax of Python. We start our while loop with the keyword while, we have some type of logical operator, and then we have the action of this line indented underneath. We can also nest while loops the same way that we nested if loops. We can drop down and actually use an if. So if I is equal to, let's say 6, let's say that we want to break. And that just means that we want to stop any of the looping action. We'll do this, we'll save and execute. And now instead of while being less than 10, we can say if I is equal to 6, we break the while loop, which is exactly what we've done here. While loops are just one more tool that we can use in our looping process. If you have any questions, please let me know. In the next video, we'll start talking about how we can use for loops in our Python scripts. I'll see you then. Let's talk about the last of our iteration techniques and talk about for looping. Here in our text editor, let's go ahead and create a string. We'll set a variable of name equal to my name again, so Derrick. Now to create a for loop, we start with the keyword for. And now what we need to specify is what we want each individual element inside the larger grouping to be called. So let's say for element in name. If you remember, a string is not just one string, but actually an array of string values. So here we have one string value here, one string value here, and so forth. Here we have 7 string values. When we say for element in name, we're saying each element, so each string value, each letter in the variable name. We can print each element, which is just what we're calling each letter in this name. So print element. We'll save and execute Python 3, and then this one is forloops.py. And now we see that for each letter in my name, we print to the terminal. We can use for loops in a lot of different ways. So let's say that we have a list A, and this is composed of a grouping of names. So Derrick, Michael, and then Jennifer. We'll drop down and we'll say for name in list A, colon, we'll print name. Now, since the elements are actually list items, instead of the individual string characters, we'll return each name through the iteration. So we'll go down and print these. Since the values making up a list are actually the groupings of the strings, rather than the individual letters making up the strings, we'll return each complete string through the iteration. If we were to put in numbers into our list, we could expect the same thing. So we'll save, and now when we iterate, we'll return all the string groupings and the numbers. For loops are a great way to pull out values, but they're also a great way to do operations. So let's create a new list. We'll say list B, and then this will be a list of numbers, 1, 2, 3, 4, 5. For number in list B, we'll say print number plus 5. This is saying that we want to add 5 to every number in the list B. We'll execute, and we see that our list of 1 through 5 now becomes a list of 6 through 10. Lastly, a for loop doesn't necessarily have to use this keyword here. Instead, we could just say print 5. This will return 5 to us for each element in the list. So since we have 5 elements in the list, we'll be returning the number 5 to our terminal 5 times. We can execute, and we see that we have the number 5 times in the terminal. For loops are one of the most common iteration practices that we'll use, and we'll get plenty of practice in the upcoming videos. If you have any questions, please let me know. I'll see you in the next video. Hey everyone, welcome to another video. So you've made it through all the tough parts of Python. You understand the basic building blocks. So let's start thinking about how we can combine those building blocks together and create functions. Let's get started. Here in our text editor, we can declare a function by using def. Now we use the name of the function that we want. So let's say that we're creating a function that adds 2.6 to any value that we pass it. We'll say add 2.6 and then put parentheses after it. Now we need to pass in the parameters that we want this function to have. Since we just want to take in a number, that means we can just assign any variable that we want here. Let's say x. Now we'll end the function with a colon. Underneath it, we need to make the action of the function. So we want to add 2.6 to any number passed to our function. We'll say result. So we're creating a new variable is equal to x plus 2.6. Now we want to print result. So this seems like a very basic example, but we can do a lot with functions here. There's a few important things that we need to talk about. A function always starts lowercase and it follows the same naming convention as a variable. So it starts lowercase and each of the words are separated by an underscore. And ideally, a function should only do one thing. So here we're only adding 2.6, which is fine. But if you need to do several different operations, you should create different functions for each of them. We'll drop down now, and we have this function created. So now we can just create a variable, we'll say amount, is equal to our function, add 2.6, and then we'll pass in a parameter, which will be treated as x. So let's pass in an integer value of 7. We'll save our file. We'll drop down and type Python 3. and then the name of the file is functions.py, we can see that we return 9.6. This may not seem like a lot, but creating a function can actually be very useful to us. Here, we just use one line of code when before we would need two. We would need to add 2.6 and then print the result. Instead, we created a function to do both of those for us. The more complex your operation is, the more useful it is to create a function. So instead of just adding 2.6, let's say we needed to add 2.6 and then divide it by 5.5. And now we start to see just how powerful a Python function is. We see that we can start creating Python functions that automate processes that we do repeatedly. In the next video, we'll talk about how we can take this even farther and start creating class objects. I'll see you then. Hello everyone. Let's dive into the true object-oriented programming nature of Python. We'll look at how we can create our first class. Let's get started. So this video might get pretty technical pretty quick, but I'll try to keep it very simple here and then put all the technical stuff in a different video later on. To create a class, it's very similar to a function. We'll call in class instead of def, and for a class, it's common to capitalize the first letter. So let's say that our class is going to be report. We'll put a colon, and then we'll drop down. Now, very simply put, a class is just an object that we can use to create other objects made up of functions and attributes. We'll create this class object here that we'll use to create other objects that we'll have to initialize using an instance. I'll talk through all of that right now because I know it sounds complicated. The first thing we need to do is to create the initializing function. We'll say def 2 underscores, which just means that this is a private function, initialize 2 underscores, parentheses, and now the first argument in your initialize function always has to be self. Now let's set a few attributes to our report class. Let's say that the report needs a title, so title, and it needs an author. We'll put a colon, and then for us to assign these, we need to say self, and then the attribute. So the attribute here is title and author. So self.title is equal to title. And then we'll do the same thing. Self.author is equal to author. So what we've done so far is that whenever someone uses this class object to create their own object, when it initializes, we're setting these attributes. So now let's drop down and create a method, which is just a function inside of a class. We'll say def and then write report parentheses, and this will take in self, and then it will also take in text. We'll put a colon and drop down, and now we want this to return to the terminal whenever someone uses it. So we'll type in return parentheses, then we'll put curly brackets that we'll use for the title. We'll say by, and then more curly brackets that we'll use to format with the author. We'll say a new line, which we can do with the backslash and then an n. We'll put curly brackets, which will be the text here. And then we'll use dot format, which is just a function that we can use to format these blanks. And then we'll pass in what we want to fill in those blanks in these parentheses. So we'll say self.title, which is just this attribute right here, self.author, and then we'll put in text, which is just the function that we use right here. We'll save this and drop down. We'll decrease our indent all the way over. That way we're out of the class. And now let's use this class. And let's say that I'm the one writing the report. My report, and then we'll initialize the class by typing the class name, so report, and now we need to pass in the attributes of our report here. The title needs to be the first one, so let's say the title is I should have studied art, and then we'll pass in the second parameter, which is the author, which is me. So we'll type in Derrick. So what this line is doing is creating a new object from the class object of report by initializing a new instance. Now that we have this initialized, we're able to use all the methods and all the attributes within the class. So we'll drop down and we'll say print, and then it's initialized here, my report. So we'll say my report dot write report as a function, which is just this method right here inside of our class object. And then we need to pass in the parameters of that function, which is just a text variable that we define here. So let's say this is object-oriented programming. We'll save the file. We'll open up a command prompt or a terminal and type in Python 3, and the name of my file is class.py. And we see that we've successfully used a method inside of a class object that we initialized here and then use the method of that class object here. The more practice that we get with class objects, the better we'll get. I hope this was a good baseline on how we can start using class objects in our Python scripts. I'll see you in the next video.